All right. Okay. Well, hello and welcome. Um, let's clear all these outputs. Okay, so today we will look at some basic data visualization stuff with Matplotlib. Okay, or Matplotlib. I'm not quite sure. This is kind of your base tool. It's not part of base Python, but this is how a lot of kind of plots are created in Python. And I'm biased. I really like ggplot in R. Um, and so in my brain, ggplot is the best. That's me. Matplotlib is still pretty good. But yeah, anyway, we'll cover using it. It's called Matplotlib because there's a lot of similarities between plotting here and MATLAB. The designers of Matplotlib were kind of took inspiration from MATLAB. And so if you've ever tried to create plots in MATLAB, or if you ever used MATLAB, some of these commands will feel will have some similarities to things there. Okay. Anyway, as always, your best friend will be the documentation, and there's a decent amount of documentation for Matplotlib, and so you'll go to matplotlib.org, and you can read the reference, and this is kind of how you use all of this stuff. Okay. Basically, the thing that we'll be using is the PyPlot kind of module within Matplot. Uh-oh. I guess I need to update this link. Okay. Well, under the API reference, PyPlot is right here. Then I must have. What is the new URL? Oh, okay. Oh no, that's it. Okay, well, I don't know what this is then. All right. Um, But anyway, so we'll import matplotlib.pyplot as PLT. That's what we'll do. And import NumPy, import pandas, and you have that. Okay, so we'll go ahead and we'll start off just by kind of creating a very, very, very simple plot. So first, I will just create a NumPy array, going from 0 to 2 pi, spaced out so that there's 500 in total. And then we will calculate the sine of x, okay, going from 0 to 2 pi. And our first plot, we will just call, matplotlib.pyplot, okay, or PLT, the pyplot dot plot, and we'll do x and y, okay? And to have it appear, you call plt.show, and then you can also put in a few options. So here I'm going to say we'll add a title that's done with plt.title, and then we can put in limits. And so we'll go from 0 to 2 pi, and we'll plot that. And ta-da, there's our picture. That is the sine of x going from 0 to 2 pi. No surprises here, right? Technically, what's going on is that there are a whole bunch of little dots, 500 of them, going from 0 to 2 pi. And what matplotlib does is it joins all of those dots with a line. And because there's so many of them, it looks like a smooth line. But really, it's just a whole bunch of dots that are connected together. Okay. Here I'm going to just go values from 0 through 0 to 4, and some random integers, 5 random integers. And the default is so I'll print out x and I'll print out y, and then the default is to join them together if you just do plt.plot and plt.show. So our values are 0, 1, 2, 3, 4. My random values in this case ended up being 4, 2, 0, 3, 0. And you can see it plots the coordinates 0, 4, and then 1, 2, and 2 comma 0, and it just joins them with a straight line. So it looks like we got this long straight line, but it's really a dot here, a dot here, and a dot here, and matplotlib is just kind of showing them. If you don't want them connected, you can do plt.scatter, and that will create a scatter plot, and this will plot the exact same ones, right? So the coordinates are 0, 4, 1 comma 2, 2 comma 0, 3 comma 3, 4 comma 0. And so these are the dots, and here they just kind of join them with a straight line. And that's actually what's going on right here. Instead of plt.plot, if I did plt.scatter, oh no. Let's see. Okay, well, the dots are so close together. It's hard to see between them, but yeah, it just kind of joins them up with a straight line. All right, so here's different random dots, and they get joined up like that. Okay. You can have multiple lines on a plot. So here I'm going to create x. X is 0 to 2 pi. We're going to calculate the sine of x, the tangent of x, the cosine of x. And here I'm going to do plt.plot x and y in blue. So I'll plot sine in blue. And then we'll do plt.plot x and z, the tangent of x in red. And then we'll call show. All right. Now, because tangent of x technically goes to infinity and negative infinity, the sine of x gets kind of flattened out. So matplotlib automatically tries to figure out what scale is necessary, and it doesn't actually go to infinity, negative infinity, but it goes up to something over 100 and something past negative 300, and over here something past positive 300. And so so yeah, you know what, the scale just, we can't really see how sine of x of is actually working. But if you plot sine and cosine together, then you're on a range. Your range goes from -1 to +1, and that shows up fine. Okay, right? So we got sine of x in blue, x and y in blue, x and w being cosine of x in orange, and we can see how that gets plotted. If you look really closely, you can see the orange shows up above the blue. Okay, and that's because we plotted the blue, and then on top of that we plotted the orange. All right, and so the orange line passes above the blue line. If you look really closely, okay. And so matplotlib figures out kind of the ranges there, okay. And the default is to put like a little bit of buffer, a little cushion between kind of your first and last endpoint of x and your first and last, max and min of y. Okay, so let's see. All right, we're going to plot sine of x. All right, you can add a few things like labels and titles. So title, x label, y label. So you call plt dot all of these things, and then when you're ready to show it, you do plt dot show. So here I'm adding labels, and so now I have, so this was without any of those things. Now I have a title, sine of x. I've got an x label x. I've got a y-axis label f of x. Okay. Here I can set the x limits. So again, the default is to have a little bit of cushion, but you can say, no, I want to go from 0 to 2 pi exactly. Okay. And then you can also do another thing like set the aspect ratio. So notice how this goes from 0 to something past 6. Okay. Whereas the vertical axis goes from -1 to 1. If you want, you can have the x and y axis on the same scale, and you'll get this, right? And this way, if you plot, the distance from 1 to 3, that's a distance of 2. It's the same distance as, say, -1 to +1 over here. Okay, so squares would look like squares and circles would look like circles when you have plt.axis equal. Here I'm going to just create a scatter plot of x and y, okay? And here I'm going to just zoom in on from 0 to say 0.2. So we'll just look at just a tiny little little amount here, okay? And so this is the sine of x, and this cosine of x starts off there, right? Cosine of x goes down and sine of x starts off at 0. And so here, if I did scatter, this is what it looks like. And here I've changed the shape of the marker and the color of the marker, okay? You can also, change the size. So here, size is small, 3. Here it's a little bit bigger. And whatever you want, you can change the size of the marker. You can change the color. Here I have maroon and dark slate gray. I think there's a few other colors. Your base colors are, you can use single letter colors like V for blue, okay, and G for green, and R for red and things like that. And I don't remember what I had. I think there's, yeah, dark slate gray. Okay, that's these are different things. So you can change, when you have dots, you can change the size, the shape of the marker. I have I think you can do like you can do a dot right there. I think you can do little triangles with a little that, and you get triangles. I think V gives you like upside down triangles. And then you can have right facing triangles using like greater than or less than, or I don't know. I think you can do stars. Okay, so you have different options as far as some of the shapes go. Okay, so here, yeah, some of the colors, you can do red, blue, green. These are single letter colors. Cyan, magenta, yellow, black, white. And then here's a list of named colors. So the single letter colors, you can also do, so this is where we have, what do we have? Medium aquamarine and purple and dark magenta and fuchsia and magenta and deep pink. Okay. And so, I have a hard time. My eyes are only so good. These 3 colors all look the same to me. Slate gray, light slate gray, I don't know. Is there a difference there? I guess you can spell gray with an E or a, and it will give you the same. I don't know, is there a difference between pink and light pink? I don't know. Those look like the same to me. Well, anyway, the slate gray looks slightly darker than light slate gray. Okay, I'll take your word for it. Yeah, okay. Line type, you can have, so this is kind of funny. Solid line, dashed line, dotted lines, and dash dot lines. Like, this is what you get: solid line, dash dot, and dotted. And I guess this would be useful if you're plotting in like black and white, where you don't have like different colors. By default, it uses different colors, but yeah, you can have different line styles. And then what else? Oh, you can change the default figure size. So I don't know what size this is, but you can do before you even kind of do before you do plt.scatter or plt.plot, you can do plt.figure, and that's going to define the properties of the figure. And again, all of these things, you do matplotlib, pyplot. So when you look for help, you'll want to type in pyplot, not just plt. Pyplot figure or something like that. Oh, look. What's it telling us? Here's what I generated for you. Certainly. Pyplot.figure is used to create a new figure or activate an existing one. Oh, look. Oh, wow. Look at this. The AI is able to do all kinds of stuff. All right. Well, anyway, I was expecting just to go to like here. Okay. But I bet, I don't know. Let's ask. Pie plot figure. I don't know. What do I want to ask? Um, plot. No, I don't know. Pie plot. I don't know. Plot. Scatter plot with diamonds. Let's see, AI. Can you do this? Oh. Well, it's loading Seaborn diamonds. Not what I was expecting. Hey, but that's pretty. Hey, you can do something. Okay. I don't know. Oh, something. Copilot. Okay. Well, anyway, um, that wasn't what had in mind, but yes, that does answer a different question about diamonds. Okay. So anyway, you can specify the figure size, and so here's a 4x4. I think I want to say it goes 7x7. Or what is this? 7x6? Is that the general size? Let's see. Is this the same size? Uh, it's a little bit different, huh? 6.5x5? Is that about the right size? No, I can't tell. But anyway, you can change the figure size that you want to do. Okay. So here's just some random values that get plotted here. Um, point size and color options. So you can change um, here you can specify some of these things. So I'm doing like we will use our size, and then for the colors, I want to do this. So this is like things get annoying. But you can put in like arrays of values for the different sizes and arrays of values for the different colors. Okay. And then alpha will modify the transparency. So here I can kind of take these same exact dots here. Okay. So you'll notice these like this triangle of dots down here. It's the same exact kind of coordinates down here. But I've modified some of the properties. You can change the size of the dots with S, okay? And so I have this array of sizes here, Z. You can change the size of the dots. You can change the color of the dots. And so, we got green, red, blue, yellow, to change, the colors of these dots. And so, if I wanted to, I could change one of these dots to say, oops. No, I can't actually. Um, but um, but yeah, this is what something would look like there. Okay. Oh, and then you can change the point markers, and so for the marker, instead of circles, I could put in stars, and this is the same plot, but now we've got different stars, and these are the different markers that you can have. So you can have the point, the pixel, the circle, up. Oh, I think I showed you the upside down and left, right triangles. And then you got these different things, the stars and the hexagons and the things like that. Okay. Generally, okay, so here is our marker reference. These are the different shapes that you can have. I guess you can have fill styles too. But anyway, we have that. Um, and and if you want, you can add a legend as well. So when you do a scatter plot or something, one of the arguments you can do is label. And then when you call plt.legend, it will add the label there. Okay, so here's a plot with some red markers and blue markers and stars and O's and a legend here. Okay. So you can do it. It's gonna be work to use matplotlib. Um, Later on, I'll show you Seaborn, I think, and that makes plotting kind of easier. So, but Seaborn is based off of Matplotlib. It just kind of has these kind of templates that make plots nice and easy. So that's kind of my preferred package. Again, ggplot is my favorite. Then in Python, I would use Seaborn. And then if I have to, I'd use matplotlib. But anyway, so okay, you can do complicated stuff. I'm not going to test you on this, right? But you can do something called subplots. And with a subplot, you basically set up like a little grid. Okay. And so here you can do subplot 2 comma 3, and that will set up a grid of plots with in this 2 rows and 3 columns. And then each plot, you can reference them. Now, because of MATLAB, these are 1 index rather than 0. So 2, 3, 1 is this top left. Plot 2, 3, 2 is this one. 2, 3, 3 is this one. And this is 4, and this is subplot 5, and this is subplot 6. And this is kind of saying, once you establish a grid that looks like this, and then within each of these plots, you can add whatever plot you have, okay? So you specify which subplot you want to do, and then once you specify the subplot, then you can do whatever plot you want. As far as our plot goes, I've just added text, but if you wanted to put in a scatter plot, you can put in a scatter plot. All right, so here is an example of a subplot where we're going to create a grid, a 2 by 2 grid of plots. And in the top left, I will plot sine of x. Top right, I'll have cosine of x. Bottom left, I'll have tangent of x. And bottom right, I will have sine and cosine together. And there you go. This is what it looks like. So you go to each subplot, and then you plot your thing. Okay. You can have even a more complicated thing with something called grid spec. Now, to make things matters worse, grid spec is 0 indexed, whereas subplot is 1 index. I don't know. It doesn't make sense to me. But anyway, with grid spec, here I'm specifying a 2 by 3 grid. But then you can say like, oh, I want to actually have a plot that spans, right? So imagine a 2 by 3 rectangle, and you can say, I want a plot that spans these 2 boxes, or I want a plot that spans these 2 boxes. Or if you wanted to, you could have a plot that spans, these 4 or something like that. And you can go through, and you have to kind of specify which part of the grid you want to create a thing about. At the end of the day, it's a pain in the butt to have to do this. And I would say very rarely would somebody go through the trouble of doing this. I would probably just make 4 separate plots. But if you're like, oh, I need to get something ready for a publication, and I want them all in one nice thing, I suppose you could go through the trouble in doing this. At that point, I would say probably use a different tool. But if you insist on doing it in Matplotlib, the tools are available. It's like, I'm going to bake a cake, and I'm going to use this hand mixer rather than like a proper tool. Okay. Let me give you a view quiz answer. Have I given you any? No, none, right? The first one, it's time for the first one, I think. Okay. The letter A. The letter A is our first view quiz answer. You guys are there, right? All right. Okay, you can make histograms. There's plt.hist. And so here I've generated some random normal values. Thanks for saying yes to letting me know you're there. Okay, plt.histogram or .hist will give you a histogram. Now you can also specify, because I don't know, we like to mess around with how many bins we have, and you can change like the color and the edge color and the transparency. So these are some of the options. So here I'm saying more bins and reduce the transparency and change your fill color and change the edges color there or something like that, right? This one, this is step filled, and this one doesn't put the lines in between here, but you get like this pattern there. Okay. All right, here I'm going to set up 3 arrays. Okay, I got random normal, mean 0, standard deviation 0.8, random normal, mean 2, standard deviation -2, and standard deviation 1, and then mean 3, standard deviation 2. Okay, and then I'm going to set up a dictionary with my arguments. Histogram type will be step filled, which looks like this. And then alpha is 0.3, density true, bins 20, edge color black. And then I'm going to create my histogram. I'm going to scatter the star quargs, okay, to scatter all of these things, because this way you can take the dictionary and then they'll become like settings. It'll be as if I had copied and pasted all of these things in here like this, okay? But I can do star quargs. And then so I'll plot this, and then this is what I get, okay? Now, the nice thing about this versus like, oh, why don't you just paste it here and paste it here, right? This is often what we do is we copy and paste things. You know, I could do it like this and that would work just fine. But then what if I wanted to change the number of bins to say 15? Okay. Well, then I have to change it everywhere. Okay. I could go 15 and 15. All right. And I could do it, but it's easier to just have star quargs. Right. So this is, and I can just have my dictionary like this, and then I could change, say, bins to be 15 right here, or I could change my alpha to like that, okay? And this is what it would look like, okay? So anyway, there is so that's that. So you can set up a dictionary with the arguments and then have all of those settings. Like if you like, there's a certain set of settings that you like, then you can have it go like that. All right, you can also create two-dimensional histograms. So here I'm going to have a multivariate normal distribution with the centers at 0, 0, and then covariance. We've got a little bit of covariance between X and Y. And then you can do matplotlib, pyplot.histogram 2D, two-dimensional histogram. And it looks like this, okay? And then if you want something, you know, like sci-fi looking, you can do something called hexbin, and it basically does the same thing, except you get hexagons, sorry, hexagons, and that looks cool, right? Anytime you see hexagons, that's an exciting day. So we have that. Okay. All right. Oh, okay. You can also do something called a mesh grid and create a two-dimensional function. So when you do X and Y, okay. So here, let me just show you. So here I said X and Y is going to be numpy.meshGrid. Okay. Big X looks like this. It's going to kind of expand. If I mesh grid X, I get 0, 1, 2, 3, and it broadcasts X there. And Y is going to get broadcast -1, 0, 1, 2, gets broadcast that way. And so if you kind of look at print X and print Y, okay, then you'll have kind of these two arrays that you can kind of coordinate here. And so if I just do X and Y together, all right, I can I'll create my mesh grid, which looks like this, and then I will apply the function X and Y together. And what do you get? You're going to get the product of, you know, 0 and 0 for this top left, and then 1 and -1 here. And then so basically this one, you know, basically the product of this and this element wise gets done there. Okay. So you're going to kind of take each of these elements, multiply by each of these elements, and you're going to do basically element wise, it's going to go through and do this. So here I'm going to do something like create a big mesh grid of X and Y ranging from -3 to +3. And then here I'm going to have the function I'm going to return will be the product of two kind of independent normal distributions. And so now I'll get kind of this big square matrix, and I can plot something called contour, and we'll get contour lines for the resulting plot. Okay, and so when you have this is basically the contour plot of multivariate normal distribution. So basically this is basically what I'm plotting right here. Just we're getting the contour plot from top down. I can get kind of the heat map version. And it looks kind of like that. I guess this has colors, but kind of something kind of like that. Okay. And that's what it looks like that. So that's imshow, plt.imshow. I don't know. Other than this demo here, I don't know if I've ever used this. Okay. All right. One of the best things about matplotlib though is you can plot directly from, say, pandas. So with pandas, you're often using data frames and series, and you can plot stuff directly from there. So here I'm going to create like a little time series with just some random values. And I'm going to create a cumulative sum here. All right. And then, and with the time series, with this series right here, this is a pandas series, you can just go call dot plot. And this is going to call matplotlib, and it will plot it out. And it will take the index, and it will automatically put index on the x-axis, which is really nice, right? Because we started, what, January 1, 2000, ending at September 26, 2002. Okay? And so just plotting some numbers there, okay? Looking at that. I mean, these are just arbitrary values coming from our cumulative sum, okay? Here you can also plot directly from a data frame. So here we're going to just make up a data frame, and here I've got data frame with column A, column B, column C, and column D. Another kind of time series starting at January 1, 2000, ending at September 26, 2002. I guess that's 1,000 days is 2 years, 9 months, 26 days. That's 1,000 days. Okay. Well, anyway, not quite 3 years. And so you can just do, you establish a figure, and then you can just call dataframe.plot. So if you just have a column with a data frame with 4 columns of numeric values, and you just say plot on it, it's just gonna plot all of these different values right here. Okay, and it's gonna use your index over along the x-axis, and there you go. And that's kind of like stock tickers or something. I don't know. Okay. If I say, hey, you know what? Let's just look at one series, and I got A, B, C, D, -1.71, -2.29, -0.017, -0.881. You can do you can take this series and do plot bar, kind equals bar, and here you get a bar, and these are negative, so they're going down. Okay. So that's that. Okay. Here's just another data frame with just some arbitrary numbers. Here I've got a two-way table. I've made up some names here: tech, agriculture, manufacturing, I guess different sectors of the economy. And then some states: California, New York, Texas, Ohio, made up numbers. You can just take this data frame and say, I want to plot bar. And you get this, okay? So here it says, all right, in tech, California has 3 and New York has 9 and Texas 6 and Ohio 1. Okay, agriculture. And then we have California 6, New York 3, Texas 6, Ohio 9. Okay, so this is just kind of a plot of basically the data that shows up in this table. You can transpose it. Okay, so normally it takes the index and puts that along the x-axis. If I transpose it, then what's along the x-axis, or what will be the index will be the states, California, New York, Texas, Ohio. And so we have that along here, and then now we have, I guess, 5 different sectors plotted there, and you have that. If you want, you can add, you can move the legend, because right here, right now, the legend is in this terrible location. So you do plt.legend, and then you say bounding box, and you'll put it into whatever this corner right here, the upper left. And this is the location. I forget. What happens if I put in 0? It gets put over there. So I think this is like where it gets shown up. And so whatever this is 1.0, I think 1.0 shows up down here. Okay. And so 0 is, oops. So I guess you assume this is 0 and this is 1 and it's kind of, you know, however you want to do it. So 1 1 and then location, I don't know, what would upper right do? Okay, yeah, it binds the corner, the upper left or upper right. Let's see, lower right binds that corner to the position 1 1. Yeah, okay. So I could do lower left to, what is that? I would want to do 0, 1. No, 1, 0. So if you want to move, you know, however you want to set things up, right? So you can kind of move the box things. Okay. You can also do plot stacked equals true. Instead of having these side-by-side things, you can do that. And again, along the x-axis, it puts whatever the index is. So here my index was tech, agriculture, manufacturing, service. And here we can transpose it. Now my x-axis will be the different states. All right, let's look at the Titanic data set. There's a few kind of things here. So remember the Titanic data set, we have information about our passengers, whether the passenger survived or things like that, the sex of the passenger, the age of the passenger. Okay. All right. One thing that's helpful, okay, is here. Let me just show you what actually. Let me show you what. So value counts, you can give it like a column, like survived, and you can do dot value counts, and it will say, hey, this is how many 0 and how many 1s you have, right? So here 0 is they died and 1 is they survived. Okay. And so here if I do survived at value counts, I have the series, and then I can just do plot. So I can just do plot kind equals bar, and then we get you know, a bar plot with how many died and how many survived. Okay. If you look at the data types on Titanic, survived is just an integer. It's a 0 or 1. And so what we can do is we can set it to be a category. So I can do Titanic.survive.as type category, replace that back. Okay, and then so now we can see survived is now category thing. Okay, and then if you have categorical data, I can rename it. So I can rename my categories. So I'm going to do Titanic.survive.cat, rename them. I'm going to rename 0 to died, 1 to survived. Okay. And so that's going to just replace all the zeros with died and all the ones with survived. So if I just do Titanic back here, you can see we got died and survived there. Okay, when you have something, when you have some categorical information, you can create what's called a crosstab. This is basically a two-way table. So I'm going to cross tabulate sex and survived, and we will get, you know, for female, this is how many died and how many survived. For male, this is how many died and this is how many survived, or something like that. So I can take this two-way table and then I can create a plot. I can do kind equals bar, stacked equals true. So I'm not introducing anything new, but I'm just showing you how it's going to work on kind of like a data set. So here I'm going to have this. And so now we can see, oh yeah, you know, there's kind of a great discrepancy, you know, as far as on the Titanic. It seems like there was a concerted effort to make sure women got put on the lifeboats versus the men and things like that. So if you were female, much higher percentage survived than the men. Okay. Here I'm just making up a variable called isChild, taking the age variable, and we're going to just say, hey, we're going to look at the age, and then I'm going to just specify, you know, arbitrarily if the child was under the age of 8. Okay, so I guess 7 and under, we will say they were a young child, and then we can create a cross tab, and we can see how many survived and how many died of children. So this will give you counts. Now these numbers, you know, these are small. There weren't that many children under the age of 8 anyway. There are like what, 50 of them, versus, you know, here we got 800 something. So one thing you can do is you can get proportions and you can use like normalize with crosstab. Normalize equals 0. This is the axis. So this means normalize across rows. So you get what, 32% and 68%. If you do adds up to 100% versus normalize 1, this would normalize down the columns so that the columns add up to 100%, 0.9 and 0.09, 0.97 and 0.029. Okay. So we'll normalize across here. And so here you can see, oh, 32% of children died versus if you weren't a children, 63% died. So so here I'll take this cross tab, and then I can create a plot here. This is not normalized. This is the counts there directly. If I do normalize equals 0, okay, now you have something that adds up to 100%, and you get that. Okay. We can do like a group by, okay, and I'll do group by passenger. I'm going to just kind of do counts of kind of the passenger ID, and this is what the group by looks like. And so I said group by sex, group by isChild, and then survived. So we're going to have female, female died, female, female survived, female child. I'm sorry, female is not child. So female adult died, female adult survived, female child died, female child survived, male adult died, male adult survived, and so on and so forth. Okay. Now with this is just a series. So if I were to just plot this, Titanic dot Titanic underscore summary dot plot, you know, this is what it would look like. It's kind of hard to read. Kind equals bar is a little bit better, but still not great because we've got what, 1, 2, 3, 4, 5, 6, 7, 8 of these things, and these are my 8 different bars. This probably not very great to read. So one thing I'll do is I'll unstack. I've got this what, hierarchical index, 3-level index actually. So here I'm going to unstack it, okay, and now I'm going to get a column for died, a column for survived here. And then now that it's unstacked, I can create a bar chart, all right? And we will get this. Okay. Um, so we have that. This is again, because the proportions on the children or the counts of children is so low, it's hard to really kind of appreciate what's going on here. And so one thing I want to do is I want to kind of normalize these. Unfortunately, I don't have a normalize function directly for this, right? So when you do crosstab, you can normalize across the rows, but I don't have something like that. I want to do something like 6 and 18 is what, 24? And then I want to say, okay, 0.25, 1/4 and then 3/4 or something, right? 0.25 and 0.75. So what I need to do is I need to get row sums. So with the unstack, after unstacking, I want to get row sums. Okay, and so now I get the row sums. This row adds up to 290, this row adds up to 24. And then so I'm going to store that as row totals. And then I'm going to divide the unstacked data divided by the row totals along axis 0. And so now I get my proportions, 0.25, 0.75, so on and so forth. And then now I can create a plot. And now we really see kind of the difference here, right? So female adults, their survival rate versus died rate around 20 something percent of female adults. 25% of female adults died. 25% of female children died. Okay. And then male children around 38% died. Okay, but then adult males, 83% died, right? So this is kind of, I don't know, it's like that movie where uh really women and children, there was a great effort to kind of make sure women and children first. All right. So that's that. I've only given you one view quiz answer. Okay, last two view quiz answers. C for number 2, E for the third view quiz answer. Okay, here's just these are just a few more arbitrary examples. Here we've made a data frame with some random numbers in there, and then once you do that, you can create a histogram based on the data frame. So you can do dataframe.plot.histogram based on kind of these kind of different columns here. And here, this is starting to show the central limit theorem. Here, if you take this first one kind of represents like random uniform dice rolls, okay, 1 through 6. And then here, if you take 2 random uniform dice rolls, you get this triangle, and then 3, 4, 5 random uniform dice rolls starts to form the normal distribution. But anyway, these are all just created using matplotlib dataframe.plot. Okay. Just a few examples, I guess, to introduce plotting with matplotlib in Python. And a lot of power comes with joining it up with pandas there. Okay, we'll end here for today. Have a great rest of your day, and we will see you on Friday.